Welcome back to another tutorial on business analytics in Excel QM. In this tutorial, I'm going to continue our discussion on decision-making topic using decision trees. Decision trees are a visual approach to decision-making problem. Any decision-making problem can be graphically represented in a decision tree. Basically, decision trees consist of decision nodes and the state of the nature nodes. Decision nodes are represented by squares, and they are basically the possible alternative or possible choice in the decision-making process. State of nature nodes are represented as circle, and those are the possible future. This is the decision tree for the lumber company example we discussed in the previous tutorial. Decision node consists of three decisions, either constructing large plant, small plant, or do nothing. And the state of natures are either the future market is favorable or not. So for each of these decisions, we have two possible future or two possible state of nature. In analyzing the decision tree, these are the 5 necessary steps. First of all, defining the problem, structure or draw the decision tree, assign probabilities to the state of the natures, estimate the payoff for each possible combination of alternatives and the state of the nature, and solve the problem by computing expected monetary value for each state of the nature node. Looking at the Thomson Lumber Company example again, this is the decision tree built from the decision table. When constructing a large plant and market is favorable for 50% of chance here, then the payoff is 200K. And if we construct a large plant and market is unfavorable, which is for 50% of the time, or with probability of 0.5, the payoff would be losing 180K. Same for constructing a small plant and favorable market, payoff is 100K. And for constructing a small plant for unfavorable market, the payoff is minus 20K. Note that here we are assigning the probability of each of state of nature happening. And for doing nothing, well, payoff is 0 for both nature. That's why we just show one payoff. So now we can calculate the EMV for each node. EMV for this node would be 50% of the time 200,000 payoff and 50% of the time 180,000 losing. So 50% multiplied by 200K plus 50% multiplied by minus 180K. That would be the EMV of 10,000. As we calculated in the decision table in previous lecture as well. For node 2, that's the same thing, the probability of favorable market multiplied by the payoff for that branch, plus 50% chance or the probability of unfavorable market multiplied by 20K loss. So the weighted average of these two branches give the EMV for node 2. Now the EMV, or the best selected decision in this node, would be the maximum of this number between 10,000, 40,000 and 0. The best EMV is 40,000 and the best decision would be constructing a small plant. So now let's assume that Thomson Lumber Company has another decision point. They want to decide whether to conduct a market survey before decision making or they don't conduct the market survey. If they don't conduct the survey, this is the same problem as we were discussing so far. But if they decide to conduct a market survey, there is 45% chance that market survey result in favorable market. They predict that the market is favorable. And there is 55% chance that they result in non-favorable market. So if the survey tells us that market is favorable and the company decide to build a large plant, still the actual future is probabilistic. If they decide to large plant on this direction, and market is favorable, they will gain $190,000. If they decide to build a large plant and market is unfavorable, then they lose $190,000. With the favorable survey result, if they decide to build a small plant and in the future it comes up that market is favorable, they will gain 90,000. And if its market is unfavorable, they lose 30,000. Similarly, if the market survey showing negative possible market and they go with large plant and in future it comes up that market is favorable, then they gain 190,000, and if market is unfavorable, then they lose 190,000. So in decision tree analysis, we basically trace back to calculate the expected monetary value. For example, the expected monetary value for node 2 is when the company decide to go for large plant knowing that the survey result is favorable, so there is 78% chance that they gain 190,000, and if market is unfavorable 22% of the time, then there is 22% chance they lose $190,000. So a weighted average of these two payoffs, considering the probability of a state of nature, gives us $106,400. So the EMV for this node is $106,400. Similarly, we can calculate the EMV for node 3 by calculating the weighted average of these two payoffs. 78% of the time the payoff is 90,000 and 22% of the time the payoff is minus 30,000. That's result in 63,600. That's a payoff for this node. And for doing nothing, the payoff is minus 10,000 always under this scenario. So we can calculate the payoff for other scenarios when the survey result is negative and company decide to go for large plan. 27% of the time they earn 190,000, 73% of the time they lose 190,000. So the weighted average of these two numbers, considering the probabilities, result in this payoff. Again, in decision tree, we trace back the EMV for this decision node would be the maximum of these payoffs. So this would be $106,400, and for this node, the maximum of this three payoff is $2,400. Now, we also calculate the EMV for node 1, which is basically a weighted average between this payoff and this payoff. 45% of the time, result of the survey is favorable. So the payoff, the expected payoff would be $106,400. 45% multiplied by this payoff plus 55% of the time, the payoff is $2,400. So plus 55% or 0.55 multiplied by 2,400. So the payoff for node 1, or the expected monetary value for node 1, is 49,200. For the other scenario, which the company decide not to conduct the survey, the payoff are same as we discussed before, and the maximum payoff here is 40,000 that goes here. Now the question is that how much Thompson's Lumber Company are willing to spend on doing the survey. The expected value of sample information from the survey is equal to the expected monetary value coming from the survey, or this can be the information from the survey, minus the expected monetary value if we don't do the survey. So if we do the survey, the average expected monetary value would be 49,200, and if we don't do the survey, that would be 40K. The difference between these two numbers is 9,200, and we call it the expected value of sample information. There is another concept named efficiency of sample information. Is basically the benefits from the survey divided by expected value of perfect information. So previously we knew that the expected value of perfect information is calculated as $60,000. So $9,200 divided by $60,000 is 15.33. In another word, market survey is only 15.33% as efficient of perfect information. So if we have a wizard who can give us the perfect information about the future, we can get $60,000 benefit. But through the survey, which is from a sample, not from the whole population, and it's not the total fact, we only can get 9,200 benefit, which is 15% of the perfect information. That's basically how the survey is efficient in giving us some information about the future so we can have a better decision making. Let's look at the Excel and how we build the decision tree in the Excel QM to address all of these numbers. So in the Excel, we can use this time decision analysis and decision tree. Let's name this as lumber company decision tree. We can start building the decision tree by adding the decision nodes and a state of nature node. So the first node here is the decision node. We are going to add two decision nodes. So in selected node 1, we are going to add two branches and two decision node. So either doing the survey or do not do the survey. After this, we are going to make two state of the nature, either survey is favorable or not. And for each of these, we are going to build three decision nodes. So at node 2, let's first rename this. This is if we conduct survey or no survey. And I can increase this. So at node 2, if I click on this node, at node 2, I can add two events this time. So at node 2, I'm going to add two branches and two events. Event 1, if its survey result in favorable, and the next one if survey is not favorable. Next time, if survey is favorable, company decide to have 3 decision, number of branches this time 3, and I'm going to add 3 decision for node 4. So decision 1, large plant, small plant, or do nothing. And if they build large plant, I still click on node 6, and at node 6, I'm going to add 2 events. So if they build large, there is a probability that market is favorable. So I would say favorable market and unfavorable market. So again, look at this example. There is 78% chance that market is favorable. So I'm going to type 78% here, and it automatically updates the unfavorable market. There is 22%. These are two complementary events. And if market is favorable here, I will type down the payoff, 190,000. And here, minus 190,000. As soon as I put the number, it calculates the payoff or expected monetary value for node 6. As you can see, we have it here. And if I continue building the whole trees, it can calculate all of this number. Let me show you the tree that I already built to save the time. So 78% of the time market is favorable, and this is the payoff. 22% of the time is unfavorable, and this is the payoff. Let me put the graph here too. So you can see that it calculates automatically the numbers exactly as we calculated in our example. It calculates all the payoffs. This payoff is the maximum of the payoff that we have here. So maximum of these 3 numbers, and that's the 106,400. This payoff is the maximum of these numbers, these payoffs. We have it 2,400, we had it here too, and the ultimate payoff is the weighted average of this payoff. So 0.40% of this payoff and 55% of time this payoff. That gives us 49,200. Similarly for this, the expected monetary value or expected payoff is the maximum of this three number, 10,000, 40,000, or 0. So an ultimate payoff is the maximum selection between these two numbers, which is 49,200. So now if we change any of these values, any of this probabilistic value, we can see what is the best payoff possible when we want to make a decision. So if I change, for example, this to 75 and this also to 75, you can see that the payoffs will change. Still, this is the best payoff, but if I change the other values, you can see which one of the option, which one of the choice gives you the best payoff. Next topic is doing sensitivity analysis for decision trees. So the questions are, if we change any of these probabilities, what happened to the ultimate decision making? So each of these probabilities are coming from the prediction or some knowledge from the market. To conduct the sensitivity analysis, instead of giving a specific number to this survey result, we use the decision variable p as the probability of a favored survey result. Therefore, 1 minus p is the probability of a negative survey result. We can calculate the payoff for this node in terms of the p. So the payoff for node 1 would be $106,400 multiplied by the probability of favorable survey, so this branch, plus 1 minus p% of the time getting this payoff. So 2,400 multiplied by 1 minus p. So if I solve this equation in terms of the p, I can get $104,000 multiplied by p plus $2,400. So now if we are indifferent in conducting a survey or not conducting the survey, I can say the payoff of conducting a survey, which we calculated from top part, is equal to $40,000. Now I can solve this equation for p, and p is equal to 0.36. It means that if the probability of favorable survey result is 36%, then the payoff from doing the survey or not doing the survey are the same. For any p larger than 36%, the payoff for doing a survey is higher. So for p more than 36%, conduct the survey. If the p is less than 36%, we do not conduct the survey because this payoff would be more than this payoff. So finding the break-even point for the probability is when it gives us some sense about whether we need to do the survey or not to do the survey. We also can use Bayesian analysis for decision making. Basically, we can use the Bayes theorem in order to find the conditional probability or posterior probability. Many ways we get that probability data. It can be a management experiment, an intuition, historical data computed from other data using Bayes theorem. So basically, if we have the initial probability about whether the market is favorable or not, and we get some new information from management, from historical data about favorable market, knowing that the survey also gives us the favorable market, then we can calculate whether the market is favorable or not, or the posterior probability. So for now, let's assume the prior probabilities are probability of favorable market being 50% and probability of unfavorable market also being 50%. This is our initial perception. We don't know what will happen in the future, but there are only two results. Either market is favorable or not. And we assume that the chance of each happening is 50%. So now we can conduct a survey. The probability that survey is positive, knowing that market is favorable, let's assume is 70%, the probability that survey is positive, knowing that market is unfavorable, therefore is 20%. Let's assume that the probability that survey result in negative perception, knowing that in actual market is favorable, is 30%, and the probability that survey result in negative market, knowing that market is actually unfavorable, is 80%. So we can use the Bayes theorem to calculate the probability that market is actually favorable, knowing that the survey result is also positive. Using the Bayes theorem, that's equal to probability that survey is positive, knowing that market is favorable, multiply by the probability that market is favorable, or the prior probability, divided by the probability of survey being positive, knowing that market is favorable, multiply by the probability of favorable market, plus probability of survey positive, knowing that market is unfavorable, multiply by the probability that market is unfavorable. So if I put the number in the equation, I can get the result. Probability that market is favorable, knowing that we get a positive feedback from the survey or from the sample, is equal to 70% multiplied by 50% divided by 70% multiplied by 50% plus 20% multiplied by 50%. So there is 78% chance that market is favorable, knowing that survey also gives the positive feedback for the market. And there is 22% chance that market is unfavorable, knowing that survey is positive. We can calculate the chance of favorable market, knowing that survey is negative also. If we input the numbers in the Bayes theorem, then we can see the probability that market is favorable, knowing that survey gives us a negative result, is 27%, and the probability that market is unfavorable, knowing that result of the survey is negative, is 73%. That's the same result we saw in the decision tree visualization. So the probability that market is favorable, knowing that survey result is also favorable, is equal to 78%. This is the probability that market is unfavorable, knowing that survey result is favorable, 22%. This is the probability that market is favorable, knowing that survey result is negative, that's 27%, and this is unfavorable market, knowing that market result is also negative. Survey result is also negative, is 73%. So basically, having some prior knowledge about future of the market, which in this example we decided to go with 50-50% of having favorable and unfavorable market, and then get the likelihood from the survey, we can update our belief or our understanding of the future market, whether it's favorable or not favorable, based on the survey result. This is where Bayes' theorem is useful for us in the decision-making problems.